Okay, welcome. Today we're going to talk some more about similar figures. So, in these pictures, we've got Papa Deer, Papa Reindeer. Come on, it's Christmas. And we're looking at these two pictures, and we want to look this one, and do either of those look like they have the same shape, but different sizes? So look at them closely and see if you can, whoops, not same, different size. That's a similar figure, right? Now, if I look at them closely, I'm looking at like the relative distance between the legs, okay? And the relative maybe girth here, all right? So this one's bigger than this one, but yet the distance is shorter between the legs. I'm thinking that's not similar. What about this guy? Quite a bit wider between the legs, but then quite a bit narrower here. Possibly. This could be, if we actually measured it, this might be similar figures, but he kind of looks like he's squished up, doesn't he? So I'm going to say no on both of these. I don't really think that they're the same shape. You know, if you disagree, then let me know, but I don't think either one of those. Let's try this one. Ooh, mama bear, polar bear. So we're going to look at number 1, number 2, and number 3. Do any of those look like they're similar in shape, but not size? Yeah, I picked this one. This one looks like it is definitely just shrunk from this picture, the first picture up here. So this would be the similar figure. The other two, again, are maybe, this one looks like it is squished together this way, so it's taller, but it's not the same. This one has been stretched lengthwise, so it's not the same. So these two here are your similar figures. So we're going to use what we've learned already with similar figures and work on some applications today. So we have this, and this is a pretty standard application problem in geometry. And what we have is a clock tower, and it has a shadow. And we have a stick with a shadow. So the sun is going to hit, both of these things the same way, right? The sun is hitting them both at the same kind of angle. So they create similar shadows. So we can use that information to find the height of the clock tower. That's what we're looking for right here. So whenever you have a problem in geometry, you want to take the information they give you and put it in your picture. So the length of our stick is 3 meters. The length of our shadow is 1.5. And the length of our building shadow, our clock tower shadow, is 8. So what we have here are two similar triangles. We have one triangle here, and then we have another triangle here. All right, so like we talked about in class, we want to set them up. So the yellow, if we do yellow to yellow, we could do it that way. And blue to blue, that's one way of thinking about it. Or we could do yellow to blue equals yellow to blue, okay? Either way, you're going to get the same answer. You can pick whatever works best for you, as long as they're set up the same way. So let's look at this first one. Let's do the yellow to yellow. So we're going to do the height to the shadow, the height of the stick to the shadow. So that would be 3 over 1.5. And so over here in the clock tower, we need to do the height. That's our x over 8. So from here we cross multiply. We have 24 equals 1.5x. So let's make that 1.5 3 over 2. I like it written that way better. And if we look at this, we've got 3 over 2x equals 24. So to get rid of our 3 over 2, we're going to multiply by the reciprocal times 2 over 3. 3 goes into 24 8 times. So our height of our clock tower is 16, and I think our units were in meters. All right. So you might want to stop the video and make sure you have this written down and make sure you can follow along. And what I'd like you to do in your notes is now set it up this way. Okay, so maybe you're going to do the height in the yellow versus the height in the blue, and then maybe the shadow in the yellow versus the shadow in the blue. All right, so I want you to do that in your notes using this other one, and then you let me know if you don't get the same height. All right, so let's try another one. So this one is a traffic light, and they've got a mirror set down here, but they're saying these are the two congruent angles. So let's do what we did before, and let's look at the information they give us, and let's put that down first. So the height from the ground to Jim's eyes is 150 centimeters. And the distance from the mirror to his feet is 100 centimeters. And the distance here is 450 centimeters. And we want to find the height. All right? So our similar triangles this time are where? You want to make sure you put them the right way. So we've got the height here, into the angle, and then back. So here we're going to have the height to the angle. I guess I should use a different color. Sorry about that. Let's fix that right quick. This was, whoops. This was 450, right? And we're looking for this. We'll just use X. And now let's get a different color highlighter. Let's use green this time. So again, we're going to go here from the angle over, then up, and then our hypotenuse, okay? So if we want to set this up, we're going to let's do the height of the green, the height of the the street light, we'll call it the street light, okay, over the, let's do the height of the man, what's his name, Jim's height, all right, is going to equal the distance from the mirror for the green. So the distance over the distance to Jim, okay? So if we take a look at that, and now we put our numbers in here, the height of our light we do not know. We know Jim's height, that's 150 centimeters, all right? And then we have the distance to the lamp, which was 450, over the distance to Jim's is 100. Okay, so if you do that, we're going to just cross multiply. 100x equals 450 times 150. All right, so when we cross multiply, we're going to have to divide by 100, right? So x equals, we've got some 10s we can get out of there. 45, whatever 45, 400, let's just keep that. 450 times 150 divided by 100 in centimeters. All right, so whatever that comes out to on your calculators, you tell me in class. The distance in centimeters. Use your calculators, use your phones, whatever. Figure it out. That's going to be one of the questions on your survey. All right? Just make sure that you've got written down right now. Make sure you've got written down how you did this. You might want to sketch the problem out, make a little drawing, and sketch it out. All right? You can stop the video. All right, here's another one. Now again, we've got to look, let's look at what information they're giving us in the problem, because that's always important to look at. So on level ground, the tree is 20 feet from the bottom of the flagpole. Okay, and the flagpole is 48 feet. It's shorter than the flagpole, and at some time the shadows are at the same point 60 feet from the base of the flagpole. All right, so that's the information they gave us. Let's see if we can put that information into our picture. So the tree is 20 feet. Here's the flagpole. Here's the tree. That distance is 20 feet. all right? The flagpole's height, they already know, is 48 feet. The tree is shorter than the pole, and the shadows are 60 feet from the flagpole. So we're going all the way back to the flagpole is 60 feet, okay? So let's look at, we're trying to find out the height of the tree. Okay, this is our Y, all right? So if we're looking at that, we're going to look at two triangles. Here's one all the way here, all the way here, and there's your triangle, all right? And your other triangle is going to be where the tree is at, and then here, okay? So let's take a look at how we would set this up. We're going to say the first triangle, so let's go the flagpole, the height of the flagpole, right? Would be we would set that up with the height of the tree. Okay, those are at both at the same places in their triangles. And that's going to equal, let's say, the overall, the distance to the shadow. So that would mean, if we're going the big triangle first, because that's what we have here, that's going to be 60 on top. Now, we're not talking about this 20 feet here. We need this distance. But we know if it's 60 and this is 20, this has to be 40. So this distance is going to be 40. That's something that you're going to have to watch because that's an easy mistake to make on your examples or on your problems. So if we have that, what was our height? It was 48 over y. Okay? So if we cross multiply, we are going to have 60y equals 48 times 40 divided by 60. Let's see if we can do this without a calculator. The 10s come out. 6 goes into 48. Isn't that 8 times? So we have 8 times 4 equals 32. All right? So check that on your calculator. If I'm wrong, please let me know. Because it's late and I'm doing it in my head. All right? But make sure you understand, again, how it was set up. Because this is the most important part, is being able to see the triangles and know how to set up your ratio. All right? One more. This one is a fun one. This is actually something that in construction, surveyors and stuff do quite a lot. So they're looking for the distance here. That, okay? So let's see, we'll need to know, in order to do this, right, we've got to look at our triangles. Always look at your triangles. We've got one here, okay? We can use that. And then our second one is here, okay? So let's do something to kind of make it a little bit easier. This distance here is going to be 7 plus 8 plus we don't know. So 15 plus x is that distance, okay? So if we're looking at our overall distance all the way, it's going to be 28 plus 15 plus x. All right, so what's that? 43 plus x. Okay, so let's set it up. We're going to say the overall of the blue is to the overall of the yellow. All right, I think it's best to kind of write out before you jump to the numbers. Some of you love to jump to the numbers, but it's best to kind of write out what you want your ratio to be so that you know before you start jumping into numbers. So then we would have the overall, oops, I don't want the overall of the yellow, sorry. I want the blue. So what do I know here? I know the base of the blue. So let's do the base of the blue. So that means this will be the base of the yellow. All right? So if we take a look at what that looks like, we've got the overall of the blue. Remember, that's what we did here. So our 43 plus x. And our yellow is just the 15 plus x. Okay? And then the base of the blue, 15. over the base of the yellow is 8. All right? So there's our equation. So now, again, we're cross multiplying. So we've got 8 times 43 plus x equals 15 times 15 plus x. So what I want you to do is in your notebooks, solve. We've been practicing this. You're going to distribute, and then you're going to solve for x. So give that a try in your notes. All right? So for your homework quiz tomorrow, or next class, you are going to have two things. You're going to have to show that you checked the one I asked you to check. So that means on your quiz, you're going to have to write out the numbers and then show what you got on your calculator. Okay? So you're going to have to go back and do that one if you didn't. And then you're going to have to do this last one. Show your work on the last problem. Now, here's the thing. I'm not going to mark it right or wrong. I'm going to mark that you knew the problem, you wrote it out, and you did it. I'm not going to tell you the problem in class. So that means you're going to have to go back to your notes. You're going to have to make sure you have this written down. And you're going to have solved it, tried to solve it. So if you just write this down and that's it, you're not getting the answer correct. You have to have actually tried to solve it. Now, if you don't get it right, then I'll show you what you missed on it, and that'll be good. But here's 2 of the questions out of your homework quiz. So I'm giving you the questions. There will be 2 others, but I'm giving you those 2. All right? So I will see you in class. Make sure you do the survey on Google Classroom. Have a good evening.